In this lesson, we're going to go over graphing inequalities and interval notation. Specifically, our objectives are to understand inequalities and compound inequalities, to understand interval notation, to graph compound inequalities on a number line, write the solution set using interval notation, and then determine if a given number is part of the solution set with our inequality. So first, inequalities. An inequality compares values. So we have a greater than or equal to, greater than or equal to. So for instance, this could look something like 10 is greater than 5, or 2 is less than 16, or actually 2 is less than or equal to 2 because of that or equal to part. A number can be equal to another number on the other side. Greater than or equal to 5 is greater than or equal to 0. Okay, so compound inequalities are when two or more inequalities are joined by the word either and or. So the inequalities that we'll be working with today involve a variable. So for instance, x is greater than 5 would be an inequality that we would then graph the solution set to, which you'll see in our examples. A compound inequality would then be or x less than -1, or we could have something like something like this. Okay, so compound inequalities are two or more equalities joined by the word either and or. And means that the solution set has to satisfy both inequalities, or means it could be part of one inequality or another inequality, and we'll go over that when we do our examples today. Some important notation. So I have this table here. Make sure you copy it into your notes or take a picture of it. We'll definitely be referring to it in the examples. So the way that it works are with inequalities, we have endpoints. So for instance, going back to the previous slide, 5 would be an endpoint of x greater than 5, -1 would be an endpoint of x less than -1, and so on. Okay, so with inequalities, if we have a less than or greater than, it means that the endpoint is not included, so it's not actually part of the solution set. On a graph, this means we would use an open circle for that endpoint. And then when we go to write the answer in interval notation, we would use parentheses. If an endpoint is included, we would see the inequality as less than or equal to or greater than or equal to. We would use a closed circle when graphing, and we would use brackets with interval notation. So in the next couple of examples, we're going to put all of this together. Make sure you have this in your notes so that you can refer to it as we're going through. Okay, so example number 1, graph the compound inequality on the number line and write the solution set in interval notation. So our compound inequality here is x less than 1 or x greater than or equal to 7. It's joined by the word or. Okay, so what we're going to do is we're going to graph on the number line all of the values, meaning x, that are less than 1 and all of the values that are greater than or equal to 7. So the lines that we draw on our number line represent x here, okay? So for the first one, let me use blue, x less than 1. So this is a less than, and my endpoint is 1. So going back, less than means I get an open circle on the graph, okay? And then values less than 1 would be 0, -1, -2, and so on. So this arrow would point to the left, okay? For x greater than or equal to 7, there's the or equal to sign. So I put a closed circle at my endpoint, and we're talking about values bigger than 7, okay? So this one right here is x less than 1. This one here is x greater than or equal to 7. When we talk about interval notation, this is where brackets and parentheses come into play. We have to describe each interval using brackets or parentheses. Okay, so make a note to yourself actually over here that infinity or negative infinity always gets a parenthesis because you can't actually stop at infinity. Okay? So intervals are written from left to right. Always left to right. If you go that means smallest to biggest. If you go the other way, it's not correct. Okay, so I'm going to do the blue one first. The leftmost place that this goes is negative infinity. And the rightmost place is 1. And now remember, open circles get parentheses. Okay, open circle parentheses. So all of those in the endpoints not included go together, and then all of those in the endpoints included go together. Okay, and we have since we have the word or, we're going to join the two sets using U, or what is also known as union. So that U is union and it denotes or, and then we move to the other set. So the endpoint is 7, and since it's a closed circle or the or equal to inequality, it gets a bracket. And then it keeps going all the way out to infinity. Okay, so this would be the set written in interval notation. Okay, now for our questions, is -1 in the solution set? So remember, with the word or, -1 either has to be part of the blue line or the green line. It can be in either one and it would be part of the solution. Okay, so -1 is right here, so that answer would be yes. Okay, for the next one, is 3 in the solution set? We would go to 3. It's not part of green or blue, so this answer here would be no. Okay, so one way to also look at when we're looking at part B is -1 in the solution set. You're looking to see, is -1 less than 1 or greater than or equal to 7? Yes, since it's less than -1, it is part of the solution set. Okay, and then again for 3 being part of the solution set, you're looking at, is 3 less than 1? No. Is 3 greater than or equal to 7? No, so it's not part of the solution set there. Okay, so moving on to example 2. Graph the set on the number line, the solution set, then write the solution set using interval notation. So this one is technically a compound inequality. You don't see the word and, but x is sandwiched in between two values. And the way that this reads is -2 is less than x, which is less than 7, or x is greater than -2 and less than 7. Okay, so let me write that down. Actually, let me write it using interval notation. X greater than -2 and x less than 7 is another way that you might see this, okay? But x is sandwiched in between, which means and. So we're going to graph it. X greater than -2, so -2 is our endpoint. There's no or equal to, so it gets an open circle, okay? And then it goes up to 7. Okay, 7 is also an endpoint, and it gets an open circle. Okay, so this is the set we're looking at. Notice here with our and statement, x greater than 2 and less than 7. So it has to meet both conditions to be part of the solution set for that one. So interval notation, since we have two open circles going from left to right or smallest to biggest, is -2 to 7. Okay, so then let's look. Part B is -1.4 in the solution set. Well, -1.4 is in between -1 and -2. So yes, that would be there. Or it would be part of the solution set because -1.4 is bigger than -2 and less than 7. Okay? Is 7 in the solution set? So we're asking if this endpoint is part of the solution set. The answer here is no, because there's an open circle here. It goes all the way up, so like 6.9999999999999 keep going, but 7 is actually not included because there's no or equal to part of the inequality. So this answer here is no. Graph the set on a number line, then write your answer using interval notation. So this one is just a regular inequality, x less than or equal to 3. Okay, so 3, there's an or equal to, so it's going to get a closed circle, and then it's going to go to the left because we're talking about values less than -3. Okay, so interval notation, working our way left to right. The leftmost part is -infinity, and infinity is positive or negative. Always get a parenthesis. And then 3 is a closed bracket because the circle is closed, or you could go back to the inequality symbol, which includes the or equal to. For our questions, is -100 in the solution set? Yes, -100, is less than 3. Okay, is 3 in the solution set? So is our endpoint in the solution set? Yes, it is. You can tell by the closed circle, or if you plug -3 in for x, I'm sorry, not -3, +3, 3 is less than or equal to 3. That's true. Okay, something that's not true, 3 is not less than 3. They're equal to each other. The reason this is true is because of the or equal to symbol there. Thank you for watching. If you have any questions, please feel free to reach out to me.